our function is f of x equal x over x squared minus 1. So our restrictions at the main, we need to equal x squared minus 1 cannot be 0. So we get that x cannot be minus and plus 1. The domain is x belongs to all real numbers except minus 1 and 1. To get x and y intercept, for x we need to equal the function to 0, and we get that x equals 0, so our point is 0, 0. And to get the y-intercept, all the function, we exchange it for 0, so we have that f of 0 equals 0, so our second point is 0, 0. For symmetry, to get even, we need to substitute with minus x, and we get that f of minus x equals minus x over x squared minus 1. So it's not equal to the original function, so it's not even. And for the odd, we need to get minus f of minus x, and it's not equal, so we have no symmetry. For the vertical asymptotes, we need to evaluate with limits of the restrictions that are minus 1 and 1, and we get infinite in all of them, so our vertical asymptotes are minus 1 and 1.
The next step is to obtain the horizontal asymptotes, and for this we need to calculate the limit from minus infinity and infinity positive, and we have an horizontal asymptote in y equals to 0. Then the next step is to find the first derivative, and for this we need to use quotient rule that says that we need to multiply the derivative of the first term times the second term minus the derivative of the second term times the first term over the second term to a square. So we have this as our first derivative, and then we need to equal the function to 0 to obtain these points. The next step is to obtain to find the ID test, and we need to use these three values because these are values between our restrictions that are minus 1 and 1. And we need to substitute this value in our first derivative, and for this we need to obtain the sign. That is what we need. If it's minus, our function is going down, and if it's plus, it's going up. And in our three values, our function is going down.
The next step is find the second derivative, and we have the first one. So to have the second derivative, we have to use quotient rule, and you know that quotient rule is the derivative of the first one times the second term minus the derivative of the second term times the first term, everything over the second term to the square. So we have this result, and we have 3 x's, so we have to clear x in each case. So we have here that x is equal to 0, that x is equal to plus minus 1, that is our restrictions, and that x squared can be minus 3 because we don't have squares to the minus. And the next step is do the concavity test, and we have these values that are in between our restrictions. So these values we substitute them in our second derivative, and we have that in minus 2 our graphic is going down, in minus 0.5 is going up, in 0.5 is going down, and in 2 it's going up. So this is our graph. We have the restrictions in minus 1 and in 1, and our graphic can pass over there, and we have odd symmetry and is passing to 0.
And our range is that our range is all the real numbers. Thank you.